Hello, this is Dr. Dennis Bielfeldt of the Christ School of Theology. We're working quickly from late medieval nominalism up to the beginnings of modern philosophy. We're in the 16th century, the late 16th century. Just want to bring a few things to your attention. Of course, you can Google all these things, but because this is part of a course, I need to bring these out at this time. Galileo in 1583 discovered by experiment that the oscillations of a swinging pendulum took the same amount of time regardless of their amplitude. I remember learning that in 8th grade or 7th grade or something, and oh, that's pretty cool. But I mean, it is quite an amazing thing to come to that knowledge in the late 16th century. At about that same time, 1583, Giordano Bruno first populated a decentralized, infinite, and infinitely populated universe. Benedicti in 1585, in his Diversarium Speculationum, foreshadowed the concept of inertia. He wrote, "Every body moves naturally or violently receives in itself an impression and an impedance of movement, impetus of movement, so that separated from the motive power would be moved of itself in space in some time." Well, our concept of inertia, right? 1586, Galileo writes a manuscript, De Motu Gravium, which shows that the ratio between the gravity of a moving body on an inclined plane and the gravity acting on free fall is the sine of the angle which the plane forms with the horizontal. I could draw that up there, but I won't at this point. I'll just move through these things rather quickly. 1592, Galileo finds that the path of a projectile is a parabola by assuming that the uniform motion preserved in the absence of an external force is rectilinear. The acceptance of a straight rather than a circular path as natural became a crucial turning point in planetary mechanics. Galileo shows up all over the place. 1600, William Gilbert in De Magnete holds that the Earth behaves like a giant magnet with its poles near the geographical poles. He coins the word electrica from the Greek word for amber, electron, and distinguishes electricity from magnetism. 1604, Kepler in Ad Vitellionum Paralipomena said that the intensity of light varies inversely with the square of the distance from the source. Well, we know this, but he found it. He said that the vision is the consequence of the formulation of an image on the retina of the eye's lens, and he describes the causes of near and farsightedness. This Kepler guy just astounds me, in case you aren't thinking today about what years he lived. He lived from 1571 to 1630. Now, Kepler is the great Lutheran science philosopher, right? Scientific guy. He writes, "I am a Christian attached to the Confession of Augsburg by a thorough examination of the doctrine, not less than by the instruction of my parents. That is my faith. I have already suffered for it, and I know not the art of dissembling." Oh, if only we knew not the art of dissembling, right? "Religion is for me a serious affair, which I cannot treat with levity." Beautiful, right? Now, Kepler just naturally assumes that God creates a universe governed by mathematical regularity. It's an artifact of the divine, after all. And so he was quite certain that if he examined the universe, he would find general mathematical principles governing the movement of the planets. And by golly, he did. Kepler's 3 laws of motion, you probably had them in high school, but they're very interesting, right? First law, the planets move in elliptical, right? Not circular orbits. Well, that's not so hard. But the second law, in any 2 equal periods of time, equal areas are swept out by the line from the sun to the planets. I could draw this on the board. I won't. But this is just an amazing discovery, right? But even more so the third one, that the squares of a planet's periodic time is proportional to the cubes of the mean distance of the planet from the sun. Wow. To find that the universe is governed by these mathematical regularities was for Kepler, who had some, like I said, pretty strong neo-Pythagorean tendencies. It was just a vindication of his faith in God. Galileo, he 1564, I believe, 1640 or so, maybe about that, spoke of his geometric method, which brilliantly hypothesizes that since there is a correspondence between geometric axioms and the empirically observable properties of moving bodies, the geometric theorems derived from the axioms will correspond to the empirical facts of motion. Now this is very interesting, because what he's saying here is if you have an initial situation out here in the world, right, and you can get, you can describe some motions here by, let's say, geometric axioms, then if you deduce from these axioms certain theorems, then you can go back in the world, and the world should instantiate or be in correspondence with the theorems that one deduces. Right? So the deduction on this side very nicely tracks with the determinism on this side. You see that? So the push towards reason and deduction really nicely pushes towards reduction and determinism. He replaces syllogistic demonstration of Aristotle with a geometric demonstration, and claims that the empirical facts of motion are necessary in the same way that the geometrical theorems are. So if you deduce these theorems and then you have your translation back to the world, these empirical facts of motion over here have the same standing as these theorems. These can't be other than they are, given this, and this cannot be other than it is, given this. See? Wonderful. Well, so the beginnings of the modern world, there's an emphasis on the individual, renewed skepticism concerning truth claims about non-empirical realities. Of course, this is the inheritance, right, of Aquinism. Natural philosophy and science becomes the model for knowledge. Natural science is altered now in what we regard as knowledge. Natural science alters what we think counts as knowledge. And natural science alters how theology is understood. And so now there develops a new relationship between science and theology. At the Institute of Lutheran Theology, should you be a student here, we do take very seriously the truth claims of theology. And if we take very seriously the truth claims of theology, we have to take very seriously other truth claims as well. And we have to understand how it is that theological truth claims can somehow connect with, link to the truth claims of the other disciplines. It's all part of the larger project. Kepler would love it, wouldn't he? This is Dr. Dennis Bielfeldt, the Christ School of Theology. We'll be right back.